Welcome everyone to the live panel discussion on the topic Platform Engineering, Unveiling the Next Evolution in DevOps. I'm your host, Dheeraj Nayal, Director of Strategic Partnerships at DASA. Hope you are enjoying DASA Connect Live Day 2 from different parts of the world. I think that's the beauty of doing it online live, that you can join in with the comfort of your home or different offices. So before we start, some housekeeping items. If you have any kind of inputs, comments, questions, please feel free to utilize the Q&A section or the chat section, which is on the right side of the screen. And we would be happy to take these questions or even answer them through chat interaction or at the end of the panel discussion as well. Great. So to provide you a brief about this panel discussion in which we have a wonderful expert of panelists today with us. So with respect to platform engineering, it has been a major trend in the past few years in the world of DevOps and IT. And in fact, as per Gartner's research, 80% of enterprises will establish platform teams by 2026 as internal providers of reusable IT infrastructure services, components, and tool for smooth application delivery. However, this change will not be without its set of unique challenges and risks for enterprises and their leaders. So are you and your organization ready for this transformation? So to answer this set of questions related to it, we have our panelists who are top-notch experts in this field, and we'll dive into what is needed to be successful in your platform engineering transformation journey. So it is my pleasure to introduce the panelists, and we will start with you, Guillermo, with a quick introduction about yourself. Over to you.
Hello, everyone. It's a pleasure to be here with you today. I'm Guillermo Martinez. I work as an executive consultant for modern engineering topics. I was going to say DevOps, but I think has evolved a little bit, so now we can mention it as modern engineering. Since we are going to talk about platform engineering today, I could share with you that I've been involved in big enterprises platform engineering projects where we've been covering from strategy to implementation, both for my company, TechTick, and in the past, I was leading all the DevOps domain in Accenture, the Netherlands.
Wonderful. Thanks again to be part of this panel, Guillermo. So next up, I'm proud to turn your attention to Govardhana. Over to you, Govardhana.
Hi everyone, nice to meet you. I hope you have a great session so far. I'm Govardhana. I'm founder of New View, which is a digital cloud transformation consulting firm. Eventually, we work clients and the enterprises to adapt latest cutting-edge technologies. I don't want to go deep into the technologies we cover, but we focus on platform engineering. I definitely see a good amount of traction and confusion around this particular space. And to bring up, we recently implemented a platform engineering strategy and also the tools, processes for Stanford University, where the end users were scientists who are actually not non-technical background. That gives the essence of platform engineering, right? Because anyone who is even not able to understand the technology behind it should be able to be self-empowered and use the platform as and when needed, so that it cuts off a lot of back and forth processes and friction. That's actually the essence. I would like to bring it on, and I'm happy to talk through in this session. Thank you, Dheeraj.
Thanks, Govardhan. And finally, last but certainly not least, Dr. Merlijn. Over to you.
Thank you. So, hi everyone. My name is Merlijn. I'm a senior researcher at IMEC, and my research is focused on software delivery. Software delivery both to cloud platforms and software delivery to edge devices. And I also teach at Ghent University in Belgium, and there I teach courses like system administration and systems design.
Awesome. So now let's jump into our first section, which is to focus on what is platform engineering and why is it important. So I'll start with you, Govardhan. So how do you define platform engineering, and how does it differ from traditional DevOps practices? If you
Mhm.
can please elaborate.
Mhm. Actually, I start with DevOps, right, which very much in place, and people think that is a technology, which is an anti-pattern. DevOps is not a technology to start with. It is a culture. It is a framework which connects the bridge between development and operations. In the process, actually, it helps with processes, tools, and automation so that the software delivery is seamless, and whatever that has been developed, it actually touch various gates of quality and security in the process if security is incorporated and reaches the production. So the focus is on delivery, but when you cut forth and come to platform engineering, the focus is more on developer productivity, self-enablement, and also the experience we give to the developers and abstraction of infrastructure. These four, I think, is the basic differentiator between traditional way of software delivery and platform engineering. So when we cut through into each pillar of it, when we start with focus, as established, DevOps is about taking your development or application to the production, which is about software delivery. The focus on platform engineering is how we actually empower your developers so that they focus on problem solving rather than behind a team to set up a tools for them, behind a team to establish an environment for them, right? So to enable that, actually they actually provided with self-intuitive portals, which we call it as self-service development portals, where they intuitively select whatever the infrastructure they want. That is the front end of it, right? So the focus element is we are actually more on developer productivity. That is the focus compared to traditional. Another thing is cultural aspect, right? When we talk about DevOps, as is established, it is more of a culture. How actually we collaborate together to enhance the software delivery. But when it comes to the cultural aspect of developer, it is about less friction and focus more on what they were meant to be, problem solvers. Again, coming to that, right? This culture actually helps them to give more with less amount of time, less amount of what is it, the pain areas. So the culturally they began to collaborate more with other parties because they are doing what they are meant to be rather than other parts of it. Another thing is tools and technology, right? When coming to the traditional way of tools and technology, all are integrated, get to the together, and is visible, so that everyone knows, hey, my build is triggered, it is in CI/CD. My infrastructure is getting ready and spin up in IAC, right? Everyone knows where it is in the chain of software delivery. But when coming to the platform engineering, we are giving the abstraction form of infrastructure. Of course, developers will go to the self-service portal and pick up, let's say, how much of storage, database, etc., etc. I press a button so that environment pops up or spins up in a matter of minutes or seconds based on the tech. But that's an abstraction form. We don't need to tell, whether it is connected to the CI/CD, IUC, or any Kubernetes structure. It is not a point of matter that curious for developers. So the focus again is on abstraction, right? You pick up what you want, you get what you want, just focus on problem solving. So to come back to the point, I'm concluding this all this pillar to the same centric point. DevOps is more about taking your application delivery forward with less friction, but adding people, processes, tools, etc. The focus is on broader, but platform engineering is to empower developers with self-enablement, intuitive portals. But at the back end, all these are connected with whatever the technology we need, which is an abstracted form.
Excellent, Govardhan. So I think there is a lots of insights which you shared, and we will now focus on the organizational structure and leadership for platform engineering implementation. So as we know that DevOps has been around with us for quite some time now, almost 2 decades. And in fact, when DASA started back in 2016, we made a strong case for treating platforms as a product and applied sound engineering principles and philosophies such as infrastructure as code. And now in 2024, platform engineering seems like a booming topic suddenly. So why do you think this is? What is new? Why do you believe what triggered the shift from classic DevOps to a more platform-centric approach in recent years. I think it would be really helpful for the audience, since each of you comes from diverse backgrounds, to provide your own inputs about this section as such. So we'll start with you, Guillermo, to share your perspective first.
Yeah, well, of course, in these 15 years, even a little bit more, since 2008, DevOps has changed a lot. And at the beginning, we were thinking like how we can make the operational part more agile, how we can embed the operational part into the development so there are no friction between them and they go together. Well, at the beginning was kind of like something easy, not easy, but not that much complex. It was more like, okay, let's bring the guys together, let's put them working together, because that way we can product software and deliver it together. So operational part, they know how is the development going, and the developers guys, they know how to deploy, how to run everything. But that was at the beginning, and it was a simple thing in that manner of, okay, yes, let's do this stuff together. But then, of course, a lot of tools came, a lot of new technologies, a lot of new practices. DevOps has been evolving a lot during these years, based on, of course, technologies, toolings, but of course also the practices, the principles. And at certain point, that was really hard to keep track with. Like, hey, the teams that they are doing development and delivery with all the new added tooling around, it has become a little bit more complex, because some developers were even complaining at certain point of, I'm not doing development anymore. I'm just maintaining my clusters. I'm learning infra code. I'm running the Kubernetes. I'm running the testing. Not developing anymore. And that's the moment where platform engineering came to the rescue a little bit, in the way of, okay, don't worry. We're going to place a platform for you that you can utilize, you can consume, so you can deliver everything that you are developing end to end. You can focus a little bit more on the development. You, of course, need to understand the whole delivery process, but it's going to be triggered through this platform. So I think this is the point that changes a little bit. Of course, we have to be careful in the terms of, we wanted to remove operation silo at the beginning, and now we might think like, yeah, but if we put a platform for that, we create a new silo, the platform engineering silo. Well, that's not true. The platform engineering works differently than just a regular silo. It's for self-consuming of the developers, which is something that removes the silo. It's not knocking the door of the platform engineering saying, hey, please, I need to deliver this, do that for me. No, it's a way to consume this platform from the engineering point of view. And of course, it has been changing a lot. It's still changing with all the new development and new technologies. But yeah, the crucial point was like at the beginning, DevOps were more like, okay, we work together. But then with the whole evolution, especially for enterprise, working together became a little bit harder. And we were looking for, at the enterprise level mainly, looking for standardization and a way to reduce complexity and make something a little bit more streamlined. And I think this is what has changed a lot. I think it's a great solution, a great practice. I think it's really working well for companies, but you need to know how to apply it, how to adopt it, how to use it. And this is the challenge.
Excellent, Guillermo. So thanks for explaining it. And it was quite explained in a beautiful way, providing some history behind that as well. So Merlijn, would you like to extend your perspective, please?
Yes, so I think one of the driving factors for the rise of platform engineering is also on the software side itself, because automation is a key concept in platform engineering, but that means that platform engineering for a long time was quite inaccessible to a lot of smaller organizations, simply because the tools weren't there yet. If you go look at how Amazon worked 10 years ago, they were actually already using this platform engineering approach, but almost every single part of that platform, they had to build themselves. Whereas right now, we're seeing a great acceleration of this trend throughout the industry because of all the great tools that are already available. Tools such as Kubernetes. And it's really interesting that containerization has actually been the driving factor of making this possible, because it makes it clear where the separation of responsibilities lie. So just as regular shipping containers revolutionized automation in the global shipping industry, containerization in software really enables this automation, because it's clear everything that's inside of the container is the responsibility of the developer. Everything that's outside of the container is the responsibility of the platform. And that's what really makes this automation possible, because you can have so many different complex and varying workloads inside of these containers that are all managed in exactly the same way by the platform itself.
Maybe at least you can place the questions in the chat and we can follow from there. Okay, he's now getting back into place. Back on track. I think
Awesome.
Perfect.
Yeah, so sorry about that. We had some technical difficulty with the platform. So that's why we are here to discuss about how to make the platforms more reliable. The audio was just toggling between on and off by its own. So sorry about that interruption. But thanks again, Merlijn, for sharing your perspective. So last but not the least, Govardhana, would you like to add anything additional what Guillermo and Merlijn have shared?
Yes, the challenges we deal with adoption of platform engineering. I think even that is a favorite question I can see in the chat right now. People struggle, enterprise struggle to adapt platform engineering. Right? That could be a best extension I can think of. There are multiple reasons, because this is very much rosy and easier said than done. We just pick up everything in front end and magically everything works in the back end, and we have a stable, reliable platform, right? But in reality, the friction starts with understanding the developer requirement. Because when we say developers, they are not a single set of people. They have, we have different types of developers: front end, back end, full stack, UI UX developers, right? The kind of development they do, their requirements is very, very different. Likewise, the workflows are very, very different, right? For example, UX may not end up in compilation, may not end up in CI/CD or move to the staging before that. Right? They have a different set of rules. So the basic point is, this is really, really a diversified pool of developers. So understanding what they need and building the workflows around what they need is really challenging, where most of the people actually is struggling upon. The next one, because one size doesn't fit everywhere. Even one kind of a business doesn't fit everywhere. I saw that what works in Stanford doesn't work in Michael Stools because of nature of business. They do. You can't take everything as one size. Another thing is perceived lack of value immediately. When we put up this, the immediate value may not be seen, because it takes some time to actually people get used to it. People get actually see through the value, because as a humans we were wired to certain kind of and processes and workflows. Immediately a sea of change comes up, a resistance pops up, or even the adoption takes time, right? That perception of value or realization of value takes a bit longer in more or less organizations, which actually make people to skeptical to step into platform engineering. Because I have a DevOps team which is doing all the kind of an support to the developers. I have an SRE, I have cloud ops, NOps, whatever. There are a lot of ops, right? Why should I bring in one more team and complicate it? This is one more question, right? That basic segregation of the boundaries, it's fits in the cultural resistance which comes in it. And the thing is integration of multiple tools here. As we speak here, as a platform, we provide a rollout. Integration plays a crucial role, right? From source code management tools like Git to Kubernetes, or even to the notification system like MS Teams or Jira Ticket for that matter, right? Everything is interconnected. We have so many interconnected endpoints. Setting it up, identifying it, running it smoothly, operationally as well, is a really, really daunting task. So it takes a lot of technical efficiency along with process efficiency and also the touch points. It is not like set it up and forget it. It's a continuous takes it again. The final point, which I mostly say, is people have questions on scalability and reliability. If I build a platform and remove the standard way of seeking the things, if it is goes down because it's a coder, right? It against change creates unnecessary chaos. That's how actually that reliability has been stepped up is a crucial KPI or the factor. And then finally, scalability. Right now it is fine, but what happens? My developer size grows to 50 to 500, right? It may be possible with startups who are early on it, or if you don't have visibility on what happens next 6 months, right? These are the challenges to be addressed, to be mapped, and go into the strategy. And there are many aspects. I see these are the main things to look for when you start with platform engineering, and these are the basic roadblocks many people also think of or not able to judge whether it is a great value creator or not.
Thanks, Govardhan. So I think with the different perspective by each of the panelists, hopefully the audience are able to relate that the evolution of platform engineering is not something completely new. There is a lots of evolution, right from agile principles to DevOps philosophies,
Mhm.
a lot of extension of SRE, cloud ops, cloud native technology. So hopefully with the inputs of each panelist, you are able to understand how platform engineering has evolved. And as part of the next section, which I'm going to ask to Merlijn, is what are, according to you, the most important platform engineering concepts and principles to get right in an organization? So over to you, Merlijn.
So we've talked already a little bit about it, but I think self-service is really one of the key critical concepts in order to get right. Um, as part of our research, we work with a lot of companies to help them deliver software faster and get better results. And sometimes we come into a company and they proudly show off all the types of tools and techniques and platforms that they use. But then when a developer, for example, wants to spin up a new service, they still need to send an email to the operations team asking them to spin up a service. And then weeks or months later, finally, the entire process is finished and they can start working on the new service. That's really not what you actually want. In order to have a real platform engineering approach, these developers need to be able to do everything themselves without having to send an email, without having to create a ticket. The platform itself should give the developers the power to do these things themselves. And then secondly, this also requires a real cultural change in your company of how developers interact with the operations team. Because the operations team really starts to become a platform team, a team that is building a platform, building common methodologies, building this self-service functionality, and then leaves it to the developers to actually interact with that platform and get what they want. This is also sometimes called internal platform as a service. So the same functionality that you would get if you get a platform from a cloud provider, this is the actual same functionality that you need inside of the organization itself. And then finally, in order to be able to make this cultural change, to give the developers this self-service functionality, you also need to have a common base. And this is basically the way to make sure that developers being able to do these things themselves, that this does not result in more security issues, or that this does not result in more in less uptime. By having the platform team build common functionalities, ensure common technologies are used for security, for access management, for authentication, you really make it possible for the developers to build stuff themselves that still meets the common goals of the company. And this is really critical, for example, when a certain part of the base technology platform, for example, when a security issue is discovered in certain base technology, then you really need the power of the platform team in order to update these base technologies, this common platform, in order to address these security vulnerabilities, almost without needing specific interactions with the developer team. So this common base, this common platform, it makes it possible to address common issues across all developers, across all developer teams, without actually requiring individual action from the individual developers. Because if you don't have this common base functionality, if you don't have this in the platform, then you will end up in a situation where reacting to security vulnerabilities, for example, is actually slowed down by applying platform engineering. While if you have this common functionality in the platform, then you can actually incredibly speed up your reaction time to security vulnerabilities.
Thank you, Merlijn. So I think you highlighted it very effectively, talking about internal developer platforms, talking about standardizations with self-service platforms, and most importantly, the cultural aspects of it. Because I think it is also a good cue for the next section, which I'm going to ask to Guillermo. And having known you, Guillermo, that you have assisted so many enterprises in their transformation journey. While many enterprises have invested in various types of IT platforms already with different tools, and far fewer have established enterprise-wide platform engineering capabilities. And it seems that truly adopting a platform engineering mindset is harder than it looks at first sight. So, what do you think are the main things enterprises struggle with when investing in platform engineering on a wider scale? Over to you, Guillermo.
Yeah, I think, well, Merlijn more or less said everything around it. I think the principles is what fails most of the times. And platform engineering has 4 principles. First of all is the prioritize the customers, and the customers are the developers. I've noticed a lot of times when an enterprise is setting up a platform engineering, they don't even ask the developers what do they need, how do they need, what kind of technologies they need to deliver. There is certain stakeholders who decides everything for the rest, and that's a big mistake because you are taking decisions without considering your users, your customers. So at the end, this is one of the big pitfalls that I see. And of course, that's important to avoid, because at the end, we need to satisfy our customers. It's an internal product. It's a product. And that's the second principle. A platform engineering, in order to develop that, you need to adopt a product mindset. We've seen in companies, in enterprises, startups a little bit less, but in enterprises, that overall we don't have a product mindset. When we are delivering products for the market, so outside internal products, we don't typically apply the product mindset. So even worse when we do something internally. So that's the second principle that I see it fails. We need to have a product mindset where the customers, again, they are the developers, and we need to understand what they want and bring it to them as soon as possible so they can be happy and they can consume the platform. Third principle is about something that Merlijn as well mentioned, which is the self-service. Just think about what's the best platform that we have nowadays available in terms of technology. We can think about AWS, we can think about Azure, we can think about Google Cloud. None of us, when we need a machine from them or a service from them, we have to create a ServiceNow ticket or give them a call or send an email. Same thing happened here. When we build a platform for internal company in order to shape software from idea to production, no single ticket should be raised, no single request should be raised. It should be self-service, so developers, the users, they can consume it and they can use it. That fails a lot. I've seen it a lot of times where you need to send a certain request in order to even open your pipeline sometimes, which is something that is out of mind. Pipeline should be a little bit simpler, easier to configure. But of course, if we move more into the deployment, same thing. You send a request in order to deploy, in order to something. That's against the principles of platform engineering. So of course you cannot achieve success if you don't even follow the regulations of platform engineering. And the last step is about improving the discovery. A platform engineering, again, is a product. A product has no end date. It's something that evolves continuously. As we mentioned earlier, technologies, toolings, approaches, practices, principles are evolving during the years, and the platform engineering should evolve. So it's not something that you start one day and you finish 6 months later. It's something that evolves continuously, and you need to apply, of course, the whole agile and DevOps mindset when you are building the platform engineering, because today we might cover 5-10 technologies that can be deployed in 3-4 different areas. Maybe tomorrow there is a new technology and we need to cover it in the platform engineering. We need to stay connecting with the developers. Hey, they have a new framework that is not covered. How we can cover it? We need to give them the chance as well to experience it, to evolve it, and then the platform engineering team or domain, they should be able to apply all these concepts. But it has not to be a bottleneck, where I've seen sometimes that the platform engineering becomes the new operations, the new silo, the new bottleneck. That's something that we have to avoid in all the cases.
Thanks a lot, Guillermo. So I think highlighting some of the inputs you shared about platform as a product, right? So aligning with the same, I think the next section I would like to ask to Govardhana is one of the reasons platforms are not always as successful as they could be is not because they are not technically sound, but because adopting from the DevOps product teams is lacking. So what do you see as key reasons for this lack of adoption? If you can please elaborate.
Yeah, actually, there are two things, right? What we wish for, what we need. Basically, when we build a product, we should build what we need rather than what we wish for. Pushing up too many features, which is irrelevant to the customers. Here, the customer is developers, as we already established that, right? So that gap is really big in all the failed implementations. It's not about technical efficiency here, because they build something which seldom developers use it. For example, rollback, right? If you push a mechanism to roll back, how many times we do a rollback? That kind of a metric zone, or who actually does the rollback? This is just a simple use case, right? But every single day, they do something like triggering a build. Every single day, they onboard people who needs new repository accesses. Every single day, we actually assign roles to based on it is a tech lead or whatever it is, right? So we just need to have the user-centric design. That's my point. Whatever you do, whatever the features you pull in or push out, it has to be user-centric, and you should have that feedback loops, etc. It's not about just set it out and forget it. You have established it, you push the iteration. It can be MVP as a typical product, but you should have that continuous feedback loop running to improvise it, right? And the thing is lack of standardization, which actually confuses the users to, because when I want to launch something in an application A, I need to go through certain kind of a workflow, but I need to pick up in another application which is same kind of a topology. I go through different kind of a workflow. This is counterintuitive, right? It's an anti-pattern. Once you establish what is being needed, you should have a standardization and roll out that standardization whatever you built for. And the thing is, we have this famous principle in DevOps, right? One-click deployments. I know there are zero-click deployments which Amazon does, but to at least the enterprises follow one-click deployment. After a point, you just need to say approve. Magically, everything has to connect it and pull the resources it want, push it and deploy it, right? Likewise, we should I predominantly see, if anything goes beyond bizarre 2 pages to fill in, if I just need to install it, it's a bizarre design. It has to be very intuitive, and has to be self-explanatory, rather than someone actually comes up and say, if I need to fill it up, I need to take a kind of a training and come back and use my platform, right? Which doesn't work, at least in 2024. People are really used to the apps. It has to be really a kind of an self-explanatory, right? And finally, the failure is, of course, there are technical challenges, but I'm not talking about it because these can be a thing. I'm putting up the behavior right? We touched based upon culture. We touched based upon it. The value has to be mostly has to be pursued from top to bottom, which is not other way around. Mostly, what I see is, at least in startups or universities, developers are pushing for establishing platform engineering because they are really fed up with going behind system admins and raising tickets and waiting for a number of days to just arrive an environment or get a pipeline to build for their application. So developers intent is pushing leadership to bring in platform engineering, but it has to be other way around. For that, leadership has to see the value. That value, as I said, it's not immediately pursued. It takes a kind of an judgment and apply. Once it has been there, you can able to push that cultural shift, push that value proposition, what actually we are bringing in across the organization. When you build that cultural shift, I think most of the friction will go away. So I just recap, right? One is user-centric design, standardization, self-intuitive. Finally, have the culture of seeing the value.
Thanks, Govardhan. And in fact, this was also asked on the chat section as well. So some of the pioneers in platform engineering are like Google, Netflix, Spotify, Airbnb. But at the same time, it's not about copying something which has been successful in other organization, but it's also about looking inwards within your own developers team, within your own infrastructure, within your own environments of how to bring in that self-service, zero-touch automation aspects to make it much more developer productivity, developer investment as part of it. And great that you touch upon the role of leadership because I'm going to quickly ask to Guillermo about, based on his experience in working with a lot of leadership team and management team, that what do you think is the importance and role of senior leadership or management team when successfully building platform engineering capabilities in an enterprise? If you can explain it briefly, please.
Yeah, I'm going to refer a little bit on what I mentioned earlier. I think the first thing is, of course, support and guidance. That's what leadership should bring. But first of all, they need to understand what is a platform engineering solution, and again, what are the principles around them. Because a leadership of management should not decide themselves how the platform should look like, what kind of functionalities it has to have, and things like that. They should be able to create a situation, a way of working where the team itself, that they bring the team that's going to bring this platform engineering, is going to be able to understand the development community and understand what do they need. And again, this is a way of leadership should lead the way, should give support, should give the guidance, should maybe set up certain boundaries, while they should not decide how to build the platform itself. That's something that it comes more internally from the needs of the people, the needs of the users. So I think that the leadership, they should understand this concept. They should be able to bring a team that is a little bit tricky team because they should have technical skills to build a platform that a lot of other people are going to consume and is going to run the whole delivery. So you really need very technical people, but you need to combine them as well with people that they are able to understand a business. They need to understand delivery. They have to have soft skills so they could understand how other people feel, how other people have the needs of delivery. So they need to be able to bring up a good team or community or domain where they have a good mix of hard skills and soft skills. And I think this is a little bit tricky because typically when we think about pure DevOps engineer, they lacked a little bit the soft skills. And if we only think about people who has great soft skills about understanding what people needs and so on, so people that are more focused about the UX domain, they have none of the technical ones. So we need to bring a team that combines both of them with both profiles, that they really work very close and they are able to, in a gradual manner, start covering all the technologies and start covering all the teams, ensuring that the consumers, the users, the developers, they are satisfied, they are happy with that. And of course, the leadership should try to push on that because it requires probably a lot of changes within the company because at the end, this platform is going to be your programmed end-to-end delivery. And some companies might be a little bit doubtful about it because, hey, how the hell a machine is going to take my software and put it into production? Well, welcome to 2024.
Excellent. Thanks for sharing that, Guillermo. So, what great insights from each of the panelists here. And now we are shifting towards the final section now, in which we'll try to keep the inputs as brief as possible from each of the panelists, because we'll be diving more deeply into the principles behind platform engineering. Although we already covered key principles of platform engineering that every organization should adopt, we also discussed about how does platform engineering influence the structure and workflow of the organization, while shining light on the business value as well. But from the infrastructure as code side, or from the security perspective, I'll come back to Merlijn in sharing your inputs about the importance of infrastructure as code in platform engineering, and maybe provide some examples of its successful implementation. So over to you, Merlijn.
So infrastructure as code is an interesting technology for platform engineering because it is important for both the platform side and the developer side. On the platform side, it is one of the enabling technologies that makes it possible to create this automation that gives developers a self-service experience. But then on the side of the developers, they are also using infrastructure as code in order to actually describe what they actually want from the platform. And so it's really at both sides of the platform boundary. So from a standpoint of the developers, infrastructure as code can really make it possible in order to have more assurances about what is actually running inside of your infrastructure. A while ago, I spoke with an organization, and I'm not going to call their names, but they basically came to me and they said, okay, we have this issue. We actually have no idea what is running inside of our infrastructure. We sometimes see vulnerability reports or new CVEs coming from a certain project. We know that some of our developers are using this project, but we actually don't know what versions of this project the developers are using. So how can we better know what is actually running inside of our infrastructure? Well, if the developer side is using infrastructure as code, then you can simply look at that infrastructure code as a description of this is the specific infrastructure that is running at the moment. And you can use that for compliance purposes, for addressing security concerns, but also for seeing where to standardize, where to improve shared concerns between all the developers. And then from the infrastructure side, yeah, it is the tool that is being used in order to automate everything.
So hoping now you can hear me. You can hear me now?
Yes.
Awesome. So sorry again because of the technical difficulties, but nevertheless, I was coming to, as part of the next sections, to Govardhana about how do you would like to explain that platform engineering contribute to innovation and operational agility in an organization? Although we have shared it briefly, but if you'd like to grasp it up for our audience perspective.
Okay.
Over to you.
Okay. Before that, I know I should take less time, but I'll split the businesses into three. Like we have in any industries, we have a large cap, mid cap, small cap. Right? Definition of platform engineering is different for each enterprise. Believe me, how they perceive as in a bank is different from healthcare. So the benefits section, right? One touches on all the businesses across is rapid prototyping, because we are an array of trying, testing, and failing, but it has to be very fast. We are living in shift left and fail fast era. So rapid prototyping actually is really, really crucial for innovation. of any kind of a product or business you are in. Platform engineering, what it does is it removes the dependency of any developer, for that matter, any executive who is using as a consumer on third parties. Also, there is no, it is available 24 by 7. There is no kind of a clock which is you need to stick on, right? Also, these are templatized, standardized. We can able to spin it up and bring it down irrespective of the time and the zone we are working on. So that factor, right? When you have the ability to build the prototypes really fast, it contributes to the innovation. Another thing is cultural aspect of it. I know one of the bad things happened with Google is they removed Google Labs. I know the innovation it used to be when Google Labs was there, right? But that kind of a labs environment is getting built up in most of the organizations where I see it, because they have a dedicated teams or sections where actually they were allowed to work on labs, allowed to work on use cases. It's not like earlier how it used to happen is a C-suite a kind of a team will decide on a strategy for next 12 to 18 months, build a strategy. In that strategy, there will be a part of a product that will be, propagated to the lower paradigm where they will test it. But it is other way around. Platform engineering is one of such catalyst, which is allowing the lower paradigm developers. When I say lower paradigm, it's not about the pay scale, it's about where we operate in a reporting structure to experiment, innovate, so that they can able to build prototypes and if it is not trash quickly, right? That's one part of it. Another thing is scalability, right? When something is built up and successful, I can able to replicate it. That's the standard of any reproducible product, right? We should repeat it, we should reuse it as many times as possible. Platform engineering actually brings that aspect of it. Also, you can able to innovate in governance space, which was not the case earlier in the platform engineering, right? When we build something with the help of security as code, policy as code, DevOps engineers used to work with security teams or panelists to plug that into their DevOps pipelines so that they will bring in compliance and reliability on the law of the land. But now, as you have packaged everything in the form of a platform, you can able to build compliance, governance, whatever it is around that package, so that whatever you start on day zero, thinking about building a platform, you are already covered that aspect as well. So these three are basic takeaways I can say platform engineering has brought in. Yeah.
Great. So I think Govardhan has elaborated quite well about the innovation and operational agility platform engineering brings into the organization. But Merlin, if you can explain really briefly about how do you measure the success of these platform engineering initiative? Over to you, Merlin.
So one of the things we see when a platform engineering initiative is successful is that the actual relationship between the operations team and the developers teams improves a lot. The same with the trust between these teams. In a traditional development environment, there's often some kind of underlying relational issues between these teams because the operations team is often a gatekeeper from the perspective of the development team. The development team simply wants to push new features, while the operations team wants to maintain stability, and so they often hold back on all the changes that the developers want to do. While in the platform engineering approach, because of this key concept of self-service, you really see this relationship improve, where it's a much more positive relationship, where instead of the operations team being gatekeepers, they're actually the experts and the providers of the platform that help the developers get to the services and the products that they actually want.
Thank you so much, Marlin. So I think this also tees up quite nicely with one of the audience question, and I'm going to ask you, Guillermo, about how does adopting platform engineering affect the culture of an IT department or company as a whole? If you can please explain briefly, please.
Yeah, I'm gonna assume first that let's imagine everyone that we adopt platform engineering in the correct way. So every team, I'm not saying developers, I'm saying every team that is building a product can build the product and send it to the platform so it goes delivered end to end. So that's not for developers anymore, that's not for IT anymore, that's for the whole company. Why? Well, basically, let's think about whatever happens before production has no value. And why I'm saying that? Because as a user, as a customer, as anyone who is using an application, a product, you have a company behind that you don't see what they are doing, and they are doing a lot of testing, a lot of checks, a lot of quality things. You as a user, you don't see that until the functionalities that they are building reaches production so you can use them. Actually, not even reaches production, but they are released. And this is the moment where you can use it, you can see that, and that's the actual value. Imagine that we are in a situation with the platform engineering that this value end to end goes quite fast. Any team, and we can think about what we were talking about, innovation or new development or new functionalities, we should be able to implement these functionalities in a comfortable manner, easier manner, of course, and then we send it to the platform, and the platform will cover it end to end, checking that everything is fine, that everything works fine, that there are no issues, that security is fine. So the whole thing is perfect, and it gets released. That means that the product will have way more constant releases, and the customers, the end customers, will see more benefits, will see what they are looking for in a shorter time. That means for the business, and again, not only for the IT, that hey, we are making more business, we are able to create more value continuously, therefore our customers are supposed to be happier, therefore we can even do more things, and therefore we know what the customers want in the next step in an early stage. So it's really a change of the whole company thanks to these kind of solutions that sometimes we might think they are not that complex, and indeed they are not that complex, but it's really a change of company because we are providing a lot of speed basically, and thanks to this speed we are able to eat the market.
Awesome. Thank you so much, Guillermo. And I think if we would have more time, we would love to extend this discussion because platform engineering has been trending, and we already see with the excitement and lots of questions coming in from the audience side. But once again, like I said, this has been a very informative panel. And before we close, we would like to give few seconds to each of the panelists here to share your rapid fire trends you foresee coming up in platform engineering. So we'll quickly start with you, Govardhan.
Oh yeah, AI is all over the place, but I don't see that is going to take it platform engineering for sure and come coming 2 to 3 years, right? But what actually expect the trend to go up is people are in a skeptical that when platform engineering arrives, most of the departments will go away, especially DevOps, which is not true. Actually, it doesn't take it away, but we get transformed to something else. Like if release engineers transform to DevOps, DevOps will transform something else. So that trend actually, when I say it, is mostly on people mindset side. Next one is data-driven decision making will be easier with platform engineering. I see that it's getting picked up, especially on the scientist who is working in Stanford University right now. They don't need to run feedbacks or surveys. They just look at the data, how the metrics, like the number of commits into a repository, build quality, build success rates is going up predominantly just looking at the implementation. So the implementations will be mostly on data driven. The people will actually going to shift to something else. AI is not going to take care of platform engineering at least for next 2 years. And also finally, I should also say that even though AI doesn't in it, but there is a kind of a machine learning activity happening even in the platform engineering just to understand the developer experience. So we may expect more machine learning models which will actually work on developer experience, and also the churn rate, right? The more the churn rate, it is bad for the implementation. So there will be models which will actually work on it, and we take decisions to reduce the churn. Yeah.
Thank you, Govardhan. So I think you kind of covered a lot of trends which we foresee as part of platform engineering. And in due consideration of time, again, I would like to thank each of the panelists today for the insightful discussion on platform engineering. And thank you as well to the audience. And like we shared initially, if you are really keen on platform engineering, DASA is hosting a webinar live on our platform engineering product suite on June 4th. And we have already posted the link on the chat. Please feel free to register. We encourage you all to join, to learn, to engage, to interact with each other as part of the learning journey around platform engineering. Thank you once again, Merlijn, Guillermo, and Govardhana, and hoping that all of you are enjoying DASA Connect as part of the live interactivity. Thanks again. Thank you so much.
Thank you.
Thank you.